Okay, here we go. Final exam review. Algebra 2. Alright, first one to solve this, we want to get the x squared by itself. So what we do is divide both sides by 5. So x squared equals 25. From here, given the exponent, we take the square root of both sides. X equals plus or minus 25. Whenever we take the square root of something and even in exponent, we always have to use positive and negative. So number 2, we want to solve this easy problem to solve by factoring. Factors of 4 add up to 5, 4 and 1, x plus 4, x plus 1. To solve this, we set both equal to 0 and solve. So we have x equals negative 4 and negative 1. This is the same type of problem. We want to find the factors of 6 that add up to 7. In this case, the 7 has to be negative, so we're going to have negative 6, negative 1. So we just kind of look at this. We want to find the opposite here. If we were to add 6 to both sides, we'd x equals 6. Add 1 to both sides, we'd x equals 1. So x equals 6 and 1. Alright, so what we have to remember with I to the 45th, we have to remember I to the first is equal to I. It's pretty self-explanatory. I squared equals negative 1. I to the third is equal to negative I. I to the fourth equals 1. So if you remember I1, go to our negative. Remember that pretty easily. Move off the screen. Okay. So from here, there's 4 of these. So we want to find groups of 4, meaning divide 45 by 4. It'll kind of cancel all those groups out. So 45 divided by 4 goes in 1 time. 0, bring down to 5. That goes in 1 time. We get a remainder of 1. So that is what I'm looking at. Remainder of 1 corresponds to these exponents. If it's a remainder of 0, it corresponds to I to the 4th. So in this case, since the remainder is 1, I to the 45 is the same as I to the 1, which is just I. Simplifies. There's a plus in between this. This is not distribution. There's a plus. Look at the difference between number 5 and number 7. Here we combine like terms. Here we multiply. There's no plus. Here we have a plus. So all we do is combine like terms. Put the i's together. Negative 1 plus 5 gives me positive 4. It's not in standard form, so we'll rewrite this as 4 plus 4i. Simply combine like terms. Same exact thing happens here, but first we have to distribute this negative. Like terms, 5 minus 4 is just I. 3 plus 2 is 5. What does this become? So look, I screwed up already. This should be negative 2, right? Negative and a positive is negative 2. So then we're going to have 3 minus 2. This here is just going to be 1. So we get 1 plus I. Right? So let's take our time with this. This next problem. Now we're going to distribute. Here we get 8 plus 4i plus 6i plus 3 squared. Combine terms in the middle. So we have 8 plus 10i plus 3 times I squared is negative 1. And we have it up top. I squared is negative 1. So that gives me negative 3. 8 minus 3 is 5. 5 plus 10i. vertex form. So you have to remember that this is in the form of a times x minus h squared plus k. And the vertex is hk. Therefore, h in this case is negative 5. And k is negative 2. So this is my vertex. Alright, simplify. This problem is similar to number 6, except now we just have variables instead of the imaginary number I. So we distribute this throughout. Be careful this time. Negative 2x to the third minus 4x squared minus 3x. So let's go in order. So I have x to the third, x to the third. So give me negative 6x to the third. Then I should have an x squared. Right? I only have one here, so that comes over. I have an x term. 4x minus 3x is just x, and then the only constant left over is minus 10. That's right. Alright, so we want to divide this. So this is being divided into here. You can do long division if you want. I really wouldn't recommend it. It's going to take a little bit too long. So we want to do synthetic division. So two things. So we're always going to solve this for x, and that's what we're going to divide by. So, for example, x plus 2, we solve it, we get negative 2. That'll be on the outside. Now in here, we need all the coefficients, however we need all the terms. 4, 3, 2, 1, 0. We're missing the constant term. So 1, 1, 1, 1, negative 1, 2. We have to fill in the 0. So always bring the first one down. We multiply, we get negative 2. Combine these, we get negative 1. Multiply, we get positive 2. That gives me positive 1. Negative 2. So that cancel. 0, 0. So the start of this is always going to be 1 less than this degree. So we have to remember here that this degree will be 1 less than this. So that's 4. This is going to be 3. X to the third minus x squared plus x. And we don't have to put the rest because it's just all zeros. So that'll be our final answer. Okay, moving on. Factor. 4 terms we have to factor by grouping. We'll group the first 2. Always include that negative with the 16, with whatever number or term is here. Makes it easier later. So here we want to factor out what's in common. So in this case with variables, whatever the smaller one exponent is going to come out. Over here, if the first term is negative, always a negative. They're both the same number. That makes it easy. This doesn't have an x, it can't come out. Okay, now what's the same? These are the same. That comes out as 1. It gets factored out. We put those together. Now we have to look. What is this? This is a difference of squares. So this will break down to what? X plus 4, x minus 4, bring over to x plus 1. The order does not matter. The order doesn't matter. Make sure we thoroughly look for those difference of squares. That was x squared minus 25 plus 5 minus 5 and so on. Okay, in this next problem, what is the greatest common monomial factor? So meaning what number or term goes into each of these, number and variable. So first numbers, 28, 16, and 4. 4 goes into everything. Now variables are easy. It's always whatever the smallest exponent is. So they all have an x. The smallest one is 3. They all have a y. The smallest one is 2. Simple. So 13 is similar to the difference of squares here. Factor. Let's say solve. This is factor. X plus 10, x minus 10. So x squared breaks up to x and x, 100 breaks up to 10 and 10. 4 requires a little bit of work, but it's not too bad. So what we have to remember is, so the question is, what is the simplest polynomial with the zeros I and negative 3? So we're looking for, when we solve a polynomial, we get these answers, meaning we get x equals I, x equals negative 3. Now what we have to remember is, where does I come from? I comes from the square root of a negative number. Whenever we get square root, we always have plus or minus. So I need the negative term as well. So we'll say negative I. Now, we want to undo all of this. Bring this over. Here we're going to have x plus I. This will be x minus I. This will be x plus 3. Pretty simple. So what we have to do next is distribute through. Always distribute the conjugates first. This is going to give me x squared. The middle terms are going to cancel, meaning we're going to get xi and ix. They cancel, positive, negative. And then when we get I negative I squared becomes positive 1. Right? Negative I squared becomes negative 1, which becomes a positive 1. Bring down the x plus 3. Well, pretty easy here. Distribute from the x to the third plus 3x squared plus x plus 3. That's the final answer. End behavior. So with end behavior, so this is going to be for both of these. We have to look at we're going to be talking about a lot of infinities. We'll be talking about a lot of infinities here. So you want to know where they are. You're always going to start all of these, both of these, as x goes to positive infinity, x goes to negative, x goes to positive, goes to negative. All this is saying positive infinity with x is talking about this side of the graph. Negative infinity is talking about this side of the graph. That's all it's talking about. What we have to look at next is the leading coefficient and degree. Leading coefficient, it's negative, it ends down. Degree is 5, opposite. Meaning, this function will end down, and the other side is the opposite. We do not care what goes on here. Right? So, when x is positive on this side of the graph, it's pointing down. That means the function goes to negative infinity. Negative is down. When it's negative, where is it pointing? Up. The function goes to positive infinity. We don't have to write a plus. Sometimes you may see it. If you see the plus, that's fine. It doesn't matter. Now, in 16, so I'm going to label this 15. Okay? In 16, leading coefficient is still negative. That means it ends down. However, the degree is even. That means same way. So, it ends down, and the other side will be the same way. So this is going to look something. We don't care what goes on here. Like this. So, positive infinity would be this side. It ends down. So f of x goes to negative infinity. On the left side, which is the negative infinity part, still ends down. F of x goes to negative infinity. Not too difficult. Okay. 17. So if we look at this, what jumps out to me, the many ways to do it, what jumps out to me is trying to cancel these guys. So if I multiply all this by -3, I'll have -3x minus 3y equals -15. Cancels. Can't combine these, but we can just write them next to each other. Cancels too. So from here, we solve this. Factor out as an x. Set equal to 0. X equals 0. X equals 3. Now we're not done. We have to plug these in to find our other variable. We have to find y. So I'm going to use the first equation. X plus y equals 5. So x equals 0. Let's plug it in. 0 plus y equals 5. The 0 goes away. Y equals 5. So for 0, 0, 5. We do the same thing. X equals 3. So 3 plus y equals 5. Cancels. Y equals 2. So at 3, we're at 2. All this is showing this is an intersection point. So we have a linear function, which is a line, something like this, and we have a parabola that hits it in 2 places. So both of these points is what these are represented as. Okay. Nothing crazy there. In number 18, we have to remember one thing. So, remembering this, I'm going to remember that if we look right here, sine is opposite hypotenuse. Opposite hypotenuse. Cosine is adjacent hypotenuse. So what we discovered is the opposite is 3. The adjacent is what? 4. And the hypotenuse is 5. So we can figure out everything else. Tangent of theta is equal to what? Opposite over adjacent. 3 over 4. Now the other 3 trig functions are just the inverse of these, meaning reciprocal. So the inverse of sine is cosecant. The inverse of cosine is secant. And the inverse of tangent, easy, is cotangent. So if we flip the sine, we get the cosecant. So 5 over 3. If we flip cosine, we get secant. 5 over 4. If we flip cotangent, if we flip tangent, we get cotangent. 4 over 5. Right, pretty simple. Amplitude is the A value, which is pretty easy here. However, we have to remember it is always going to be positive. We see it being negative, it's always positive. You have to remember that. In number 20, we have secant and cosecant. Let's always write things as sine and cosine. So secant is the same as what? 1 over cosine of theta. Cosecant is 1 over sine of theta. Well, now what we do is flip this around because 1 over, 1 over, all this becomes is sine of theta over cosine of theta. Well, sine of theta over cosine of theta is just tangent. Right, I'm going to stop there for this portion of the review. Right, I will upload this immediately, and I will continue numbers 21 through 40 at a later time. Keep studying, and good luck.